Hello everybody, today I am going to show you the experiment Microstrip power divider. So it is Microstrip power divider. It is having three ports. This is port 1, this is port 2, this is port 3. So the main characteristics of this Microstrip power divider is whatever power you are going to apply to this input port, that is going to be equally split among these output ports. Before going to this power divider, I will write the diagram of this power divider. The aim of the experiment is to determine power division and isolation characteristics of Microstrip 3 dB / 6 dB power divider. It is there. What we are using is 3 dB power divider. In this, the aim of the experiment is you have to find out two characteristics. One characteristic is power division characteristics, another one is isolation characteristics. So I will write the diagram of this. This is port 1, this is port 2, this is port 3. And port 1 to 2 there is a coupling. These are called coupled ports. 1 to 3 these are also coupled ports, but 2 and 3 are called isolated ports. You remember this, 1 to 2 there is a coupling, 1 to 3 there is a coupling, but 2 and 3 there is no coupling. 2 and 3 ports are isolated ports. You remember this point. While considering power division characteristics, we have to consider port 1 to 2 and 1 to 3. For isolation characteristics, we have to consider port 2 and 3. For 1 to 2, you should do the connections like this. Input you apply to port 1, output you take it across port 2. The remaining port 3 you should not leave blank. You have to use this matched load, matched termination. Terminate port 3. This is you have to do the connections. In the same manner, for 1 to 3 you have to give input to port 1, take output across port 3, terminate port 2. In this case, while doing power division characteristics, these are the connections you have to do. For isolation characteristics, you have to consider, as I told, 2 and 3 ports. Input you have to give to port 2, take output across 3, so terminate the port 1. This is how you have to do the connections. This is the power divider. Before doing this, you have to take reference frequency and power. Reference frequency I will take 2.3 gigahertz and power I will take minus 45 dB. So I will show you how to adjust this frequency and power before inserting this actual power divider. Before switching on micro signal generator, keep these knobs, maintain these knobs for their initial position. Sweep rate minimum, RF power level minimum, and 1 kHz. If it is in release condition, take it back to extreme left at click sound. And all these push buttons are in release condition. These are the knob positions you have to maintain. Next, coming to this VSWR, keep the knob to 40 dB and gain maximum. All these push buttons release condition. By maintaining this, you have to switch on the source. Initially, first take the frequency knob and adjust the frequency to 2.3 gigahertz. Then go for pressing this modulation switch, that will switch us over to AM square modulation. Next, RF button. Next, you insert this 3 dB attenuator pad. 3 dB attenuator. Next, connect through the cable. This is connector. And detector. detector and this BNC and connect to VSWR meter. Before that, keep it to 40 dB, gain maximum, all this release condition. Switch VSWR on. You can use any one, either these two channels, input 1 input 2, provided you select this switch. If you press this input 2, you have to connect, release this input 1. Now frequency adjusted 2.3, vary the RF level and observe on VSWR meter so that needle moves so you have to consider the last but one scale, dB scale. Now the needle position is at 5. What is the range of the range knob is at 40 plus 5 minus 45 dB is the power now. So I adjusted 2.3 gigahertz and minus 45 dB. This is initially how to adjust. And coming to your tabulation for power division characteristics, initially you have to vary the frequency starting from 2.3 to 2.8 giga. Meanwhile, you have to note down VSWR meter reading without power divider, because power divider I have kept outside the setup now. Still I am not using power divider. Only I have directly connected source to the meter and adjusted this frequency and power. So first reading will become as it is, 2.3 minus 45 dB. Then you see here, you just goes on increasing the frequency 2.3 like this, 2.4. Note down the respective reading. So what is the power is not the power, needle position is 4, range is at 40 plus 4 minus 44 dB. Likewise, you have to take the readings 2.3 to 2.8. Note down the respective readings. That is that this column is named as VSWR meter reading without power divider. Now coming to this column, this is a very important column. Now I am actually inserting the power divider. See here, after taking from 2.3 to 2.8, again come back to 2.3, again the power will be 45 dB only, initial power 45 dB. So you remove this detector, everything in on condition. Now I will insert the power divider. Input I am giving it to 1, taking output across port 2 and terminating with this 50 ohms load port 3. See, input I have connected to 1, where I need to check the output. I have to put the detector there. Detector input I have connected to port 1, detector I have connected at the port 2, port 3 is terminated now. Now this column is called, you can designate it as P2 or P3, since the port I have written, this is P2. Now take the readings from 2.3 to 2.8 and this column is over. Observe here in the tabulation, take the readings from 2.3 to 2.8, this column is over, output at port 2. Then you just come here, concentrate here, this is important point, just interchange these two. Interchange the ports. Now I am terminating port 2, taking output across port 3. So this column is designated as with power divider, voltage with power divider. At output I am taking at port 2 and port 3 for the frequency 2.3 to 2.8. Come here. So this completes the power division characteristics. Now I have taken the output at port 2 in one time and at the output at port 3. While taking, I am terminating the other port. Input is common to the port 1. This is for power division characteristics. And the remaining columns are, you can fill it out with the help of the graph calibration, Q dash, R dash, P dash. You can use that calibration graph and fill that readings, and you can calculate the X and Y Finally, you need to check that this value should come around 3 dB. Since what we are using is power divider, the value of that is 3 dB. So this is the tabulation power division characteristics. Initially what we have done is we have increased the frequency without power divider. I have noted down the readings from 2.3 to 2.8 and respective VSWR meter readings without power divider. With power divider, as I shown, we have taken one time at port 2, one time at port 3. In the meanwhile, terminating the other ports. So up to this, the readings are over. This Q dash, R dash, P dash and X and Y, you can fill it out with the help of this calibration graph. This is very simple. In x-axis you have to locate the VSWR meter reading. In the y-axis the corrected value. You have to locate first your VSWR meter in the x-axis and see that where it is intersecting with the middle line, locate that reading. This is your corrected value. In the y-axis you can get this. Example they have shown here 48 they are locating. The actual 48 reading of VSWR meter reading is 49.5. Now we have completed power division characteristics. Now we have to go for the isolation characteristic, the second tabulation. The second tabulation, the first and second columns are same, 2.3 to 2.8, initial reading is minus 45. Only thing is we have to take one reading at port 3. So how it is, I will show you. For isolation characteristics, input you have to give to port 2, take output across port 3, terminate port 1. Now I will show you. For power divider, input I am connecting to port 2, take output across port 3. So which one is the remaining port? That is port 1. You have to terminate this with this load. So this is how the connection you have to do for isolation characteristics. Input I am connecting to port 2, taking output across port 3, terminating port 1. Input to 2, output 3, terminating 1. So here you observe here the isolation, it will come in 60 dB only, because the isolated ports there is very less power flows in between them. So you are getting the readings more negative. 70 dB you are getting there. You can observe. So same procedure, you have to vary the frequency from 2.3 to up to 2.8 like this. Meanwhile, note down the readings of VSWR meter readings. See here in the tabulation they have provided 2.3 to 2.8 you have to vary and note down these readings. Output at port 3 with power divider. So this is reading. For P dash, Q dash, I and this you can calculate these all these with the help of that calibration graph. And your power division characteristics, the first two columns and isolation characteristics first two columns remains the same, because we have not changed any power here. 2.3 minus 45 we have adjusted. Here also same readings will come. Only thing is that the different port the readings will change. So this is how you have to consider the ports. This is for power division characteristics and it is for isolation characteristics. So this completes the experiment. Thank you.